And so, all right. Number one, find the x and y intercepts and sketch the graph. Okay, x equals 0, y equals 0. 0 plus y equals -3. Y equals -3. 0, -3. Which is right here. Okay, now y is 0, x plus 0 equals -3. X equals -3. -3, 0, which is here. Perfect. Okay. Number 2, x equals 0, y equals 0. 0 plus 2y equals -8. 2y equals -8. Y equals -4. 0, -4, which is here. X plus 2 times 0 equals -8. X equals -8. -8, 0. Okay, this is annoying. -8, 0. Gonna be right there. That's okay. Okay, anyone have any questions about the first two before we move on? Find x and y intercepts, sketch the line. This was on your chapter 2 test, and it's also on your chapter 3 test. So just want to keep this topic fresh. Okay, now we're going to do number 3 and 4, which are just graphing lines. So scooch down to those. Y equals x minus 2. So the y-intercept is -2. Start with a dot there. And both of these, I picked these because they have kind of strange circumstances. So in this one, the slope is 1. How do I graph a slope of 1? Well, I take the 1 I put it over 1 because anything over 1 is still itself. And it's positive, so I'm going to go up and over. So up 1 over 1. Okay, last warm up number 4 is -3 over 2x. And what I want you to do is add a +0 on the end so that you can see that b is 0. And the slope is -3 over 2, which means I'm going to go down 3, right 2. So 0 starts at 0, down 3 over 2, down 3 over 2, and then backtrack. Okay. You can take your packet and scooch it to the side. I don't think we were doing anything else in the packet today. I'm just going to bring you guys a note card, and we're just going to use it for the right angles on the edges. Don't worry, that's not an upcoming test or anything. This is just literally to be perpendicular. Okay, so for number 25, what we want to do is I want to talk about what you guys did without me on Friday. And I want to go back and we can just look at mine. I want to go back and look at my picture. I really make you do the same picture for number 6. Okay, anyway, we're gonna look at my problem number 40 because it's like the same thing. Okay. So we're gonna look at this picture right here. And I want to talk about 3 different things about reflections. So first of all, do you guys recognize this as a reflection? Okay, would it help if I rotated it like that? Can you guys tell that that's a reflection? Okay, so there's 3 things I want to talk about with reflections before we move on from that topic. And that is first, the original triangle and the new triangle are both equal distance from line L. Okay, so write that down real quick. And then I'm going to go back and talk about what I mean by that. Okay, so if I'm looking at this picture, if I measured it, which we don't normally do, this is about a centimeter away. And this is about a centimeter away. This is about 2 centimeters away. This is about 2 centimeters away. What I mean is this point and this point are the same distance from the line of reflection. Okay, the second thing I want to talk about is the naming of it. Actually, the second and third. So triangle PQR becomes triangle P prime, Q prime, R prime. And this symbol means new or changed. And is called prime. I really wonder if Optimus Prime is called Optimus Prime because he's like new Optimus. I don't know. Do you guys know who he is? You know who he is? Anybody know who he is? He's like the Transformer dude. Yeah. I just wonder. Okay, and then the last thing is the original is called the pre-image, which I already wrote wrong. It needs an R in it, which I need to put there with whiteout, which is lost in my, oh, here it is. Pre-image. And the new is called the image. And I'm telling you that just in case that language comes up in your homework or on a worksheet or something where it says make the pre-image into the image. That just means take your original and make it into the new. So original figure and then reflected figure. We're also going to do rotations and translations in this class, just not yet. Okay. All right, now I You guys have this part already done, but we're gonna draw a picture down here, a couple of pictures. I want you to grab that note card that I gave you. And we're just gonna use it for the right angle bit of it. What I want to do is figure out what the slope is of something parallel and something perpendicular to the slope of one. Okay, so come down into the space over here, anywhere, and just make a dot. It doesn't matter where it is. And what I want to do is think about what we did on our warm-ups. What did the slope of one look like? It was up 1 over 1. So that's what a slope of 1 looks like. Okay, now here's some vocab. What would a line parallel to that look like? Parallel. Just visualize it in your mind. What would a parallel line look like? Actually, it would be the same, which is weird. So a parallel line would look like that. Those two lines are parallel. What's the slope of that line? 1, okay. Okay, now here's where I want you to use your note card. What I want you to do is take the 90-degree corner of it and put it against one of the dots. So you're making a 90-degree angle. And then mark down the note card a couple of boxes so you can see what perpendicular would look like. Perpendicular means 90-degree angle. So I made a 90-degree angle with my note card. And put that 90-degree angle in your diagram. What is this slope? Mm-hmm. Okay, now we're going to start to work on -2, and I want you to notice some pattern recognition. So our goal here is to be able to draw the picture for 2 and then not draw a picture for 3/4 and see if we can pick up the pattern. Okay, so we're going to do a slope of -2. So start up high this time, down 2 over 1. Here's your slope of -2. Okay, then draw a parallel slope. What's the slope of that one? -2. Okay, so are you willing to make a guess about the slopes of parallel lines? Equal slopes. Perfect. Parallel lines have equal slopes. So what would be a slope of a line parallel to a line with a slope of 3/4? 3/4. No need to draw the picture. We know because they're parallel, they have the same slope. Okay, but perpendicular is not that easy. So take your note card. Line it up to one of the dots at a 90-degree angle. Mark around the note card in a couple of spots like I did. Put in your 90-degree angle. Okay, and then I'm actually literally going to throw in a slope triangle here because I want you to see what the slope is on this one. So this is 90 degrees. Rise of one, run of two. So my slope is 1/2. This is a much more difficult question than the previous one. What do I have to do to -2 to get it to be positive 1/2? There's actually vocabulary words for that you may or may not know. Anybody know what to do? What can I do to -2 to get positive 1/2? Even if you don't use the proper vocabulary, what's one thing you notice that they have? This one's negative and this one's positive. Okay, that's called opposite. Opposite means that you switch the sign. What else? 2 and 1/2 are. It starts with an R and ends with reciprocals. Okay, so these two are called opposite reciprocals. Opposite reciprocals. That means that you switch the sign and flip it. Okay, so taking that information, what would the perpendicular slope be to 3/4 if you switch the sign and flip it? -4/3. Switch the sign and flip it. Okay, now come back here. This one just switched the sign. What happened here? What happens when you flip 1? What's the flip of 1? It's still 1. Spicy. Okay. So now we're going to take that information and do actual math problems instead of drawing pictures. No, Mrs. Talbot, I like pictures. Okay, so first thing I need to do is teach you some notation. I don't know about you, but I'm way too lazy to write the word perpendicular all the time. There is a math symbol for it. It looks like this. Upside down T means perpendicular. You can write that anytime that you want to write the word perpendicular, but you're too lazy, which is great. Okay, so what we're going to do is find our perpendicular slope and B. Okay, perpendicular means opposite reciprocal, which means I have to flip this and change the sign. What is the opposite reciprocal of negative 2/5? Positive what? 5/2. Okay, now this is the most important thing. It's perpendicular to this line, but this is the B. This is the B because it's the y-intercept that this line's going to go through. So -3. You don't end up using the 6, so you have to just kind of ignore it. Okay, so y equals 5/2x minus 3. Okay, now the symbol for parallel looks like that. It's just two bars right next to each other. It looks like 11m, but it's parallel slope. Okay, what did we learn about lines that have parallel slopes? What does parallel mean? Equal. So the slope is 3/2 and B is 7. Y equals 3/2x plus 7. Okay, now we're going to do notes on this and then we're done. Okay, so we're gonna do notes on this. We're gonna do this both algebraically and graphically, because sometimes you'll have a graph and sometimes you won't. So I need you to be able to do both ways, but we're going to make sure that our graph matches our algebra here. So I'm hoping that it will really help like make the connection about what's going on in these problems. If you're a person that really likes the graphic way, you could always make a graph, but a lot of times it asks you to do it algebraically, so we need to know how to do both styles. Okay, so the first thing we need to do is define what parallel lines are for our class. Parallel lines are lines that have equal slopes. So M is equal. But different y-intercepts. Okay, so what I mean by that is they have equal m's, but their b's are different. So they have equal slopes, different y-intercepts. Okay, so we're going to graph it first. We're going to graph the one that they gave us. So it says a line through -2, 0, which you can graph right here. So there's -2, 0, parallel to y equals -5x plus 3. Okay, so go up 3 for the y-intercept of that. And then the slope is -5, so go down 5 over 1, down 5 over 1. This is a really steep line. Okay, so the question is asking me, give me the equation of a line through this point that's parallel to that one. And can you kind of picture where it would be? It'd be like here. Do you see it? Can you guys picture it? So a line through this one that's parallel to this one. Okay, so because they have the same slope, you're going to count the same number of boxes. So down 5 over 1, down 5 over 1. Okay, and what is B in this parallel line that we made? How far down is that? Well, it was 2 sets of 5. Does that help? We're having trouble counting to 10. That's a difficulty we can't do today. Okay. So the final answer to this problem is y equals -5x minus 10. However, we need to do it algebraically also. Okay, so what I want you to do is over here, write parallel slope x equals y equals. Parallel slope x equals y equals. Okay, now here's my slope, -5. What's the parallel slope to that? -5. Remember, parallel lines have the same slope. So if the original slope is -5, the parallel slope is -5. And then x and y is the point that they gave you that it goes through. Y equals mx plus b. 0 equals -5 times -2 plus b. Zero equals 10 plus b minus 10 minus 10 -10 equals b. Do you see how my graph matches my algebra? And it's satisfying. Okay, now you guys realize that's the easy one, right? Okay. Anybody need more time with this picture? Yes? Okay. You're good now? Okay. All right, last problem of the day. And in this problem, I'm going to prove to you that the algebra is sometimes your better option. Because I know a bunch of you guys are just like, I'm just going to draw the picture, which is great, except when it's not. Okay, we're going to define perpendicular lines. Lines that have opposite reciprocal slopes, opposite reciprocal slopes, and different y-intercepts. Lines that have opposite reciprocal slopes. What does opposite reciprocal mean in like easy language? What does it mean? Flipped and sign switch. Both. So this word means flip. This word means change the sign. Change the sign and flip. Okay. So let's graph this guy here. Oh, let's graph this point. So -1 is right here. And then this line is y equals 2x plus 3. So okay. Okay, now notice I'm gonna make it even bigger. I made the point -1 really big because that's where it's telling me to put my note card so that I can count the boxes. Although I made it so big now, it's hard to see where the note card should be. Okay, now this one's a little harder to tell. Not so much the slope, but can you guys tell what the y-intercept is? What do you think it probably is? 1/2? It's probably 1/2. But when it's like not perfect, then we go to the algebra. We're like, okay, it looks like it's probably 1/2. Let's see what it actually is. So I'm going to write perpendicular slope, x, y. Here's the slope. Here's x. Here's y. Okay, what's the opposite reciprocal of 2? -1/2. Beautiful. So switch the sign and flip. And when it's a whole number, remember, put a 1 underneath and then flip. And then x is -1, y is 1. And if you want to, if you need it, put something like this off to the side just so you can see what happened to get the -1/2 if you need it. Okay, and our instincts were right. B is 1/2. Final answer, y equals -1/2 x plus 1/2. How much do you want to bet that this dot has bled through like 17 pages of my notebook? Maybe just like 3. Oh, hey, just one. Pleasantly surprised. Okay, do you guys know what the homework is? 32 through 37. And tomorrow we're going to work on rotations. 90 degrees, clockwise, counterclockwise, all that stuff.